All right, so our job in the first part was to determine how many solutions am I going to find. Now we're going to take things a step further. We're going to actually figure out what those solutions are. So let's start with the first one. I have a discriminant of 8. That doesn't tell me what the answer is. It doesn't tell me what the solutions are. It just says it's positive. So you're going to two real solutions. So let's write that out. So 2 real solutions. Okay, so what I want to do now is I want to figure out what those solutions are. So we're going to go back a section, and we learned about the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, one part of that quadratic formula should be really familiar based on what we just did. So if you look inside the radical, we have b squared minus 4ac. That is the same as what we found with the discriminant. So I'm not going to rework all that rework that problem out. I know the discriminant in this problem is 8, which was b squared minus 4ac. So let's start filling in what we know. So x equals, I have negative b. I know b was equal to 4, so I have negative 4 plus or minus the square root of 8, because b squared minus 4ac was equal to 8 from right here. So I just took it and I plugged it in. All over 2 times a, and we said a was equal to 2. And from there we simplify. So I have x is equal to negative 4 plus or minus the square root of, and to give myself a little more space, I'm going to break 8 down. So we have 8 breaks down to 2 and 4, 4 breaks down to 2 and 2 of a pair of 2's. So that gives me 2 square roots of 2 all over my denominator is 2 times 2, which is equal to 4. And then from there, I'm going to separate the rational part of the problem from the radical. So x is equal to, I'm going to put both of my parts in my numerator, so the negative 4 and the 2 root 2, I'm going to put them both over the denominator individually. So it gives me negative 4 over 4 plus or minus 2 square roots of 2 over 4. And then I'm going to simplify both fractions. So x is equal to negative 1 plus or minus 2 over 4 reduces to 1/2, so 1 square root of 2 over 2, so root 2 over 2. Okay, and those are my two solutions. So I have negative 1 plus root 2 over 2. I have negative 1 minus root 2 over 2. And now I'm going to do the same thing with the middle problem. So let's kind of partition things off here. Okay, so the second one we said the discriminant was 0, so I have one real solution. So I should end up with one real solution when I'm done. So I'm going to kind of adjust the screen here so I can see my a, b, and c again. So I'm going to write out my quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac. So I see that discriminant again, that b squared minus 4ac, over 2a. So I'm going to start substituting my numbers in. So negative b, I know b was equal to 4, so negative 4, plus or minus the square root of, I know the discriminant, b squared minus 4ac, ended up being 0. So I'm going to substitute that 0 into the radical, all over 2 times a is equal to 2. So x is equal to negative 4 plus or minus the square root of 0 all over 4. If I take the square root of 0, I get 0, so x is equal to negative 4 plus or minus 0 over 4, which gives me x is equal to negative 4 over 4, which is x is equal to negative 1. So we said in this case, we were supposed to end up with one real solution. Negative 1 is our one real solution. So in the first one, we had two solutions. Second one, we had one real solution. Now in the third one, we're going to do this one more time. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Or x is equal to, start substituting the numbers in, negative 4 plus or minus the square root of, we said our discriminant was negative 8 all over 2 times 2. So we start simplifying from there. And now I have to deal with this negative square root. So the first thing I'm going to do, I'm going to leave the negative 4b plus or minus. I'm going to factor out the I, square root of 8. So I factor out the square root of negative 1, which was the I, and it becomes a positive 8. All over 2 times 2 is 4. And we said already we can break 8 down with a factor tree. So I have a pair of 2's with a 2 left over. So x is equal to negative 4 plus or minus. 2 goes to the outside with the I, square root of 2, all over 4. Now I'm going to separate the real part from the imaginary part. So x is equal to negative 4 over 4, just like we did in the first part over here. We separate the rational from the radical, plus or minus 2I root 2 over 4, and then we simplify our fractions. So x is equal to negative 1 plus or minus I square root of 2 over 2. So 2 over 4 reduces to 1/2. So it's 1I over 2. And you'll notice both of our answers, negative 1 plus I root 2 over 2 and negative 1 minus I root 2 over 2, both have an imaginary number, so we don't get any real solutions. So our complex number would be negative 1 plus or minus I root 2 over 2. All right, so now I want you to do the same thing with the problem you had earlier. So your problem is 3x squared minus 6x plus 3 is equal to 0. I want you to figure out what x is, which is what we solved for in all three of these problems up here. X is equal to, x is equal to, x is equal to. Okay, so I want you to figure out what x is, and I want you to put your answer in blank 1.